हेलो स्टूडेंट्स, आज हम देखते हैं क्लास 10th चैप्टर नंबर 1 यूक्लिड्स डिवीजन लेमा पे बेस्ड कुछ क्वेश्चंस. लेट्स सी few questions based on Euclid's division lemma of chapter 1 class 10th mathematics. Question. First question. Show that every positive integer is of the form 2q, and that of every positive odd integer is of the form 2q plus 1, where q is some integer. Question is, show that every positive even integer is of the form 2q and that of every positive odd integer is of the form 2q plus 1, where q is some integer. Solution. Let's see the solution. Let a be any positive integer. Let a be small a be any positive integer and b equals to 2. Let a be any positive integer and b equals to 2. Then by Euclid's division lemma, there exist integer q and r such that a equals to 2q plus r, where r is greater than or equal to 0 and less than 2. See, when we divide a by 2, we get a quotient q and r which satisfies Euclid's division lemma to get a relationship a equal to 2q plus r, where a is dividend, 2 is a divisor, q is quotient, r is remainder. Now r is greater than 0 and r can be equal to 0, but r is less than 2. This is the condition as per Euclid's division lemma. So when r equal to 0, we get a equals to 2q by equation 1. It is even since it is multiple of 2. When r equal to 1, a equals to 2q plus 1, it is even plus 1 odd. We know that an integer can be either even or odd. Therefore, any even integer is of the form 2q and that of any odd integer is of the form 2q plus 1 for some integer q. This is all about the explanation of why every positive integer, or we can show that every positive integer can be expressed or can be written in the form 2q, and that of every positive odd integer can be written in the form 2q plus 1 for some integer q. Now let's see another question. So that any positive, question number 2, show that any positive integer is of the form 3q plus 1 or 3q plus 2 for some integer q. Solution. Let's have a look of the solution. In this case, like previous one, we assume let a be a positive integer and b equal to 3. Why? Because we have to write it, or we have to show it in the form 3q plus 1, 3q plus 2. That means we have to take the divisor 3 here. Applying Euclid's division lemma with a and b equal to 3, we have a equal to 3q plus r and r is greater than or equal to 0 and less than 3. For some integer q and r, we get a equal to 3q plus r. Now we have three conditions for r. R can be equal to 0, 1 and 2. So when r equal to 0, a equal to 3q. When r equal to 1, a equals to 3q plus 1. When r equal to 2, a equals to 3q plus 2 by equation 1. Thus any positive integer can be written in the form 3q plus 1 or 3q plus 2 for some integer q. Now there are few questions which you can do or practice for yourself. Show that any positive integer can be written in the form 4q plus 1 or 4q plus 2 or 4q plus 3 for some integer